handout. So somebody help me out. What would the square root of x to the 6th?
X to
And what do you have to be careful about?
Oh, put the bracket thingies.
Those two values. Right? Because what can't come out of a square root? What can the result of a square root not be?
negative.
Negative. So let me follow that up. Everybody with me? The answer to a square root cannot be negative. So let me follow that up with this. What's the negative square root of 9? Negative 3, 11. And then somebody says, what the shit? What's the square root of 9? 3. And then there's a negative on it. So the result of the square root was 3. Why is this negative? Because it's a freaking negative. That's why. What's this?
It's not a real negative.
Not real. You can't multiply a real number by itself and have the answer come out negative. 2 negatives multiplied by b. 2 positives multiplied by b. So there's no way in hell this is going to work. Later we will be able to do something with this. But right now we just say not real. I like it. So don't make this the answer to any math problem you don't know. I would love that. I don't know how to do this. Not real. It's not real. It's fake. It's fake news. Precisely. Okay, so that's some of the basic stuff. Okay. So then what about, what the hell would this mean? What's a way to rewrite this? No, okay. All right, let's start off with this. What does a cube root do to something?
Splits it into thirds.
Splits it into thirds. We already have a symbol for multiplying something by 3. It's multiplying something by 3. So I wouldn't make a whole new symbol for that. So what's the cube root of 8? 2. Why? Because if you cut 8 into 3 parts, multiplicatively, it's 2 times 2 times 2. So that's why there's another way to write this. In my opinion, better way to write this. You guys might not agree with me because you're more used to this symbol. But the better way to write this is x to the 1/3. Because it takes 1/3 of something multiplicatively. So what would 27 to the 1/3 power be? No. Break 27 up multiplicatively. 3 times 3 times 3. So 27 to the 1/3 is 3.
And that's the same as cube root?
Yep, it's the same. And what's the cube root of 27? Well, of course it's 3 because these are the same. It's just 2 different ways of writing the same thing. It's sort of like if somebody wrote, oh my God, it's a powerful marker. Or it's a weak ass rag right now. God, these refillable ones suck. I can't get shit off of that. All right. What was I about to write? What was the last comment somebody made?
I don't know what I just said.
Shit. Well, all right. So if I have the cube root of 64.
8.
No.
4.
4 times 4 times 4. So the cube root says, I want to take 1/3 of it multiplicatively. So this is 3/4. So the answer will be 1/3 of that. So the answer will be just 1/4. It's like what goes in the little dude in as cubes. We put 1 of each in the little dude, 2 of each. So that little dude was actually the cube root. It was 1/3 of what it was made of. So another way to write cube root of 64 is 64 to the 1/3 power. They mean the same thing because this is 1/3 of 64 multiplicatively. Why multiplicatively? Because what's the exponent based on? Multiplication. So this symbol makes complete sense if you let it. That spot indicates multiplication. So if I want to cut something in thirds multiplicatively, I put 1/3 in that spot. That's what it means. I like it. Another way to look at this is, what does it take 3 of to multiply to be 64? It takes 3 fours to multiply to be 64. There you go. That's what that really is asking you. So what would this be? Yeah, what does it take 5 of to multiply to be 32? It takes 5 twos. 2 times 3 times 6 times 2 times 32. Okay, maybe. So let's try that thing I was talking about earlier. So x to the 2/3. What's the root? Third root of x to the second power. I love it. Now I could also put this as cube root of x and put the second power out here. These are both the same. I love you guys. Now wait. We'll get there. So watch. If you don't quite believe me, my God. Somebody else. So let's take cube root of x squared. Isn't this, how do I rewrite the cube root? What power?
1/3.
1/3. And what do I do with those powers? Multiply. All right, let's try this one. How do I rewrite the inside? Cube root of x is x to the
1/3.
1/3. What do I do with these powers? So you get x to the same damn thing. So it doesn't matter if you put the square on the inside or on the outside. As long as this says 2 things. It says cut it in thirds and square it. It doesn't give a shit which one you do first. This is squaring first. This is cutting in thirds first. It doesn't care. It just wants both things done. Right? Clean your room and clean the dishes. Which one first? Do something. Right? I don't care which one you do first. Get them both done. Does that make any sense at all? Okay, so watch. So here's how I can tackle a computation problem with this. You gonna work better here? Yes. Okay. So if I had to do this, 27 to the 2/3. Since we're not as used to this notation, I can transform it into radical notation. What's the root? Third root, because roots are on the bottom of plants. So the number on the bottom is the root. We have a choice to make. I can put the 2 on the inside or on the outside. Do you want to do the cube root of 27 squared? Do you want to square 27 first? I don't, because I know the cube root of 27. I'd rather do that and then square it, right? So normally when I have a number, I'm going to put that power on the outside, because then this is a hell of a lot easier to look at. What is the cube root of 27? 3. What's 3 squared? 9. Now just to point this out again to you guys, and this is not necessarily a way to do this problem. Break 27 up into 3 parts. 3, 3, 3, right? This says take 2/3. What's 3 times 3? Okay. So this says 2/3 of 27 multiplicatively. Well, it's 3, 3, 3, so 3 times 3 is 9. That's 2 of them. That's neat. It's not necessarily a way I would solve the problem, but it is kind of neat to realize there's a whole other way to look at it. That's why the result, if this power is less than 1, the result is less than the number was. You guys are like thinking about that. So watch this. It's kind of nifty. It's kind of nifty. What is 9 squared? 81. 81. What's 9 to the first? 9. What's 9 to the 1/2? 3. Right? Half of 9 multiplicatively. If the power is 1, it's the same. If the power is bigger than 1, it comes out bigger than it was. If the power is less than 1, it comes out smaller than it was. Which kind of makes sense. This is half of this. So of course it's going to be smaller than that. Okay? Yes?
How do you cube root something when you can't immediately see like what it splits into?
All right. So if it's a problem that will work, so for example, this will work. Let me think for a second. It will work. Hold on. Let's do that. I like that. Scheiße. Yeah, you can kind of tease this out. What's the cube root of 64? 4. What's the cube root of 125? 5, right? So this isn't that much above 125. So, and what number goes into 729?
9.
9, because 7 plus 2 plus 9 is a multiple of 9, right? In fact, 9 goes into how many times? 9 goes into 72.
3 times.
9 goes into 72. 8 times. 9 goes into 9 once. And then 81 is?
9.
So this, another way to look at this is, what is this number made up 3 of? Right? So it's made up of 3 9s.
It's fine if we put that into the calculator though, right? Or do you want to see all that work?
I will tell you if you can use a calculator. Normally, if I don't say, don't use a calculator. You should know this about me by now. All right? It's not your calculator that I want to pass this class. Yes?
So you can start by doing like to the second, and then add that other one, like 9 times 81, and then 9 times 9.
Yes. Because, so if you have a big ass number in here that you can't just tease out what it is, you start to factor it. Because why is the cube root of 27 3? Because 27 is made up of 3 3s. I don't really have to do this step though, because I can see it in my head. I know it's made up of 3 3s. What's 729 made of? Can you see it in your head? No, shit, I need some help. I better write it out for myself. See what it's made out of, right?
Can you break it up again one more time? For like the 9 times 81.
Yeah, there it is. So 7 plus 2 is 9 plus 9 is 18. That's a multiple of 9. Remember that? I told you that a while back. If it's a multiple of 9, when you add them up, 9 goes into it.
Mm-hmm.
So 9 times 81,
Okay.
and then 81 is 9 times 9. So I found 1, 2, 3 things that make this. So what does it take 3 of to make this? 3 9s. That's why the answer is 9. The answer to a root is always the number that you need this many of to make this. That's the question a root asks you. Okay. Last thing to review, and then I'm going to unleash you on this thing. Domain. Might be a trick question a little bit. How do you figure out the domain of this? What kind of root is it?
Third.
Third root. Is there any number that you can't put inside of a cube root?
Yes.
What kind of number? What's the cube root of negative 8? What's the cube root of negative 8? Negative 2.
Oh, negative.
Why are cube roots okay with negatives?
Oh, 'cause it's an
because
odd
3 negatives will multiply to be negative, right? So it's only even roots that can't handle negatives. So this is not really a trick question. This is a valid question, but if it's an odd root, it's all real numbers. Odd roots can handle negatives. We've done several cube roots of negatives. Why does it work? Well, what's negative 4 squared? 16. See, it always makes it positive. So you can't do the square root of a negative number without getting really freaky. But what's negative 4 cubed? Negative 64. So a cube keeps negative. So a cube root can handle negatives because that's a possible output for a cube. That's why odd roots can handle negatives. Even roots, really uptight. They're like, shit, I can't handle it. So if I said the same thing, so this would be all reals. Because is there any x that freaks this guy out? Nope. But what if instead it was this? Now it's got to be true about the thing on the inside. Did I ever start that? Probably not.
No, that's not 14 minutes.
Oh, it's gone? Okay. Yeah, I'm sorry. So the inside has to be at least 0.
Oh.
And then you solve and you get 7. Why did I have to do this? Because it's an even root. It can't handle negatives. If it's an odd root, you're golden. You can handle positives, negatives. All right, so here. That's all you need to be able to do this. And it's a side that's got less colors on it. It's the 10-1, 10-2 side. The back is 10-3. We haven't done that one yet.